Hi everybody. This is going to be a quick lesson on the Pythagorean Theorem. A lot of you might have already heard of this. It's a theorem that we named after the mathematician that invented it. His name was Pythagoras. He was an ancient Greek mathematician. Not a lot of important stuff to know, but it's just some interesting background here. And the Pythagorean Theorem has to do with right triangles. Now, when we talk about right triangles, you're talking about a triangle that has a 90-degree angle in it. So when we look at that, sorry, I got a little bit of lag here, but we're talking right triangles. They have 90-degree angle. And for the purposes of keeping it consistent with the formula, we say this right angle is at angle C in triangle ABC. So we say angle C in triangle ABC. Okay, and so what we discovered, what this mathematician discovered basically, is that within a right triangle, in order for it to be a right triangle, the sides always had a specific proportion to it. No matter what happened, no matter what calculation they ended up doing, the sides always had a specific proportion, a ratio of the sides, if you will. And it made an equation that looked like this. When we name the sides of a triangle, we name it by the angle that is opposite the side. So when I look at angle A, which would appear right here, if I go to the side opposite it, this side right here, side BC, would be named A, with a lowercase a. This angle B would go down here, and so side B would be this side. And side C would be here. And that basically points out that the hypotenuse, which is the longest side, is C, and legs, the other two sides of the triangle, are A and B. So when we're given this information, a right triangle, got a 90-degree angle with angle C and ABC, and we have a hypotenuse that is C in this case, legs are A and B in this particular case. They always had a specific formula that described the relationship between these sides. Gonna leave a little extra space here. But it would be this. The sum of the sides that are the legs, so A and B squared, equal C squared. So if we add A and B squared, each of them, they would equal C squared. It always came out that way. As long as it's a right triangle, it always equals these. Now, a triangle where this ratio is true is called a Pythagorean triple. Pythagorean triple. Now, you're going to see some problems here where you might be asked, given three measures of sides, is this possible? Can this form a Pythagorean triple? You may see examples where you are given two of the sides and you got to figure out the third one. One useful skill, I'll put a nice star here for you in a second so you know it's an important point, but when you need to solve for a missing side of a right triangle, try using your rewriting equations skill. Now, why is that a pro tip? Because I can rewrite this equation if I need to solve for A. You can think of A as, get my pencil here, the square root of c squared minus b squared. Because if we looked at this, I could subtract b to the other side, and I get c squared minus b squared, and then take the square root of a squared to get a. You could think of then, if I were to need to solve for b, a different side, which you wouldn't really need to do because the names of the sides are arbitrary. That means you can make them whatever you want. It doesn't really matter. So you could always solve for a or always solve for b. The important thing is that you know the difference between legs and hypotenuse. So if we looked at this relationship, then rewriting this in terms of b would give you c squared minus a squared, and then the square root of that would be b. Or as my computer is letting me know I can always save stuff here. There we go. We could also say c equals, in this case it'd be just a slight difference. It'd be the square root of a squared plus b squared. So there's a little background into this guy right here, okay? Now, just to give you the couple of examples here, how would this apply to it? How do we find if things are Pythagorean triples versus solving for missing sides? Let me just give you a couple of examples of how this would work out. Don't need arrows, I want these lines. So I'll give you one example with a diagram, one example with numbers, and then one of the Pythagorean triple. And hopefully this will be enough of an example for how to do things. Not the prettiest thing there. Bear with me. Let's say that I give you 3 here, 4 here, and then I need you to find c in this case. Now c is the hypotenuse, right? So your original formula here is a squared plus b squared equals c squared. Can't exactly do superscript with my keyboard, so let me just draw it on there. So if this is my starting formula, again, I can rewrite it to get this. So I can rewrite it to c is the square root of a squared plus b squared. And you're going to want to put this in parentheses here, just so you know you do that first. And then I just plug the numbers in, which is why the rewriting equation skill that we learned in the last class is really, really helpful for this. So for this guy, I would just go ahead and plug in. A is, in this case, either side, doesn't matter. We have a 3 and a 4, why not just do them in order? The order of which one's A versus which one B actually doesn't matter at all in this case, unless they tell you to solve for a variable of them. So then you would get this, and then from here, you can do this. So you just go equals, and then we would say it's the square root of, so 3 squared we know is 9, 3 times 3 is 9, and 4 squared is 4 times 4, which is 16, and that would equal the square root of 9 plus 16, which is the square root of 25. Okay, and that would be 5. So C, the missing side, would be 5. They create a Pythagorean triple because they all add up to create a right triangle, basically. A squared plus B squared will equal C squared. Okay? Now, let's say that we are given just two numbers. Let's say that we say A equals, let's go with, why not 6? And let's say that C equals 10. And they want you to find B. Well, again, we know the formula, and then we say that C is the hypotenuse in this case. We'll just assume we know that. In other problems, you may see things where they'll tell you what the letters are and which one's hypotenuse, which one isn't. So I'll just put this here. I'll put this here for now, and then put this here. I'll just type the things underneath them this time. So we know that this is true. And with that being true, we can again rewrite the equation. See, B would be the square root of C squared minus A squared. Oh, that's why that wasn't working. There we go. B equals C squared minus A squared. Now, again, we can just plug in the numbers here. So if I see this, this would equal, well, C is 10. So this is going to be 10 minus 6. And that's going to be, make sure we have their squares and stuff. Get this here. And we just put the squares there. And so the next step we see here is it's going to be, that's going to equal, well, we know 10 squared is 100, and 6 squared is 36. All right. I take the square root of that. And that's going to be, well, 100 minus 36 would be 64. And then from here, that would equal 8, because the square of 64 is 8. So B in this case would be 8. So something you'll notice as you do these kinds of problems is that the hypotenuse is, of course, always the biggest side. So when we start to look at these questions, and they ask, and they give you 3 measurements, let's say, of sides, and they ask, is this a Pythagorean triple? In order to know that it's a Pythagorean triple, this must be true. All right? So A squared plus B squared would have to equal C squared. And C, because it is the hypotenuse, is always going to be the longest side. So regardless of whether they give you A, B, and C, or they just give you numbers, you know C always has to be the biggest side. And because we know that, we know where to put each number when we test this. So sometimes we can think of, is this a Pythagorean triple? Or we can give you 3 side measurements and ask, is this a right triangle? Because in order for a triangle to be a right triangle, the Pythagorean theorem must be true. But likewise, if the Pythagorean theorem is true, it's a right triangle. We call that using the converse of a statement in math. Converse would be you just flip the order of it. Now, we're not going to do the Pythagorean example here. Is this a Pythagorean triple? You'll just know that, well, if this is true, if you can have a squared plus b squared equals c squared, two shorter sides squared add together to create the square of the longest side, you know it's a Pythagorean triple, and therefore it is a right triangle.